All right, topic 7. Go ahead and turn to page 101. Page 101. I know my shirt's changed. This is actually a different day. It's actually the last day before spring break, so I'm going to be seeing a lot of you tomorrow, but you will not be seeing me when you're watching this, most likely. All right, let's dive in. All right, in this topic, we're going to start to go over transformations. This one and the next one, in fact, you're going to see this problem on both because this topic, we are talking about the dependent variable. So that's going to be kind of, it's going to affect the input. I'm not sure if you remember, we've talked about this in the past. I can review dependent and independent variable more when we get back. But all you mostly need to know is that is going to be f of x plus k and k times f of x. So let's talk about those. You have already seen these at this point. We have practiced this. You just might not be used to seeing it written out like this. In this case, k can be a lot of different things. So if you have plus k or minus k, let's say that was 5, it would shift the graph up 5 or negative 5, down, it would shift the graph down 5. So f of x plus k refers to when the graph shifts up or down. K times f of x, if you remember, let's just say that we make the graph negative, and so k was just -1 or just a negative, it could flip the graph. The graph would become reflected. However, let's also say k is 2 or 3 or 1/2 or 1/3. It's going to make the graph either shrink and compress or expand, stretch. So it's going to vertically stretch or compress the graph. All right, so for this first one, it's kind of broken down similar to what we already did. So let's go through this. We have a table, and we're going to plug in different numbers to f of x, and then we're going to see what that would look like if we transformed f of x. So let's plug in -2. F of x is x squared plus 1. Very easy. So we plugged in -2 for x. -2 times -2 is positive 4. So -2 squared is 4. Plus 1, we get 5. G of x. G of x, if you notice, we're taking our answer for f of x and then adding 3. So 5 plus 3, that gives us 8. All right, now let's look at h of x, or is f of x minus 3. So 5 minus 3. We get 2. Now we're going to do the same thing with -1. -1 times -1 is positive 1. 1 plus 1 is 2. Now we're going to add 3 to our f of x. 2 plus 3, we get 5. And then same thing, but minus 3. 2 minus 3, -1. 0 squared, easy, 0. Oh, sorry, plus 1. 0 squared, 0, and then it's plus 1, so 1. All right, f of x plus 3, so we're just doing 1 plus 3, you get 4. And then 1 minus 3, you get -2. Now, you'll notice for this next part, it kind of repeats itself because when we did -1 squared, that became positive 1. 1 times 1 is also positive 1, and then plus 1, so you get 2. And then when you have, if f of x is 2, then g of x is 5, and h of x is -1. Same thing for 2. 2 squared, 4, plus 1, 5, just like we did in the first part. If f of x is 5, then g of x is 8. If f of x is 5, then h of x must be 2. Hopefully you understood that. And now we're going to kind of discuss and look at how that transforms the graph. All right, so our very first equation, f of x equals x squared plus 1. If we plug in our points, let's go to -2. We have, that was 5, -1 was 2, 0, 1, 1, 2, 2, 5. So our graph looks something kind of like this. Now let's look at if we did +3 to f of x. Remember, those points are going to be 8, 5 at -1, 4 at 0, 5 at 1, and 8 at 2. So it looks exactly the same. It's just moved up 3 units. Now h of x, when we plot those points, you're going to notice the same pattern. Again, it's the same graph, it's just shifted down 3. Right. Now let's look at what that would be if we took f of x again, but this time we either gave it a negative, or we multiply it by 2, or multiply it by 1/2. So we already know what f of x is. We have 5, 5, 2, 1, 2, 5. All right, so g of x, all we're doing is taking f of x and making it negative. So -5, -2, -1, -2, and -5. All right, h of x, we are doubling everything. We're multiplying everything by 2. So 5 times 2, we get 10. 2 times 2, we get 4. 1 times 2, we get 2. 2 times 2, we get 4. 5 times 2, we get 10 again. All right, hopefully you follow so far. And then with j of x, we are halving everything. So 5.5, or 5 divided by 2, I mean, not 5. 5.5. 5 divided by 2, which is a little over 4, about 4.5. 2 divided by 2, which is 1. 1 divided by 2, or 1/2. Again, 2 divided by 2, we get 1. And 5 divided by 2, which is, again, is about 4.5. All right, let's see what those look like on a graph. All right, so we already know what f of x looks like. All right, so now let's plug those points, but let's make them all negative. And we get something that looks kind of like this. So we've discussed this in the past, but if you put negative in front of any function, it's going to flip the graph or reflect the graph. Now let's look at it when it's times 2. So so we have 2, 4, instead of and then 10. So it looks more like this. So notice the graph compressed. It became smaller, if you will. So whenever we multiply a number greater than 1, it compresses the graph. Whereas if we multiply a number less than 1, but greater than 0, which we're going to see with j of x, it expands the graph. So everything becomes a little wider. So again, multiplying a bigger number, it will shrink, it'll compress, whereas 1/2 or like 1/4 or 1/3 or a fraction, it will expand the graph or stretch the graph. All right, so we are given a function, f of x equals x squared plus 2x plus 1. And we are going to manipulate this function or transform this function. For the first one, we just want it to go up 5. So, as you've already seen before, you're going to do f of x plus 5. So, if we plugged that in, it would look something like this. Let's combine like terms. 1 plus 5 we get plus 6 instead of plus 1. Easy peasy. Now we want to do down 8. Well, instead of plus 5, we are just doing minus 8. So similar, we're going to do 1 minus 8 because those are like terms. And instead of plus 1, we have minus 7. Hopefully you see how we are able to get those. All right, and now we're going to write a function that vertically compresses the graph by 1/4 units. So we are going to multiply 1/4 by f of x. This gets a little tricky if you want to multiply it out because you're going to basically multiply 1/4 times this whole thing. The only thing that'll mostly change is where we have our constant of 2x, because 2 times 1/4 is 1/2. So it would look like this. All right, hopefully you followed along. Feel free to pause and take a moment to write this all out. All right, now we're going to stretch the graph by 6. I wish they switched the compress and stretch on the 2, and maybe that was on my end. But basically, we're going to multiply 6 by f of x. So when we multiply 6 times f of x, you're going to end up multiplying 6 by the whole thing. So break that down, you get 6x squared plus 12x plus 6. All right, and now we want to reflect the graph. So as we've discussed again, when we want to reflect the graph, all we do is make everything negative. So if you multiply -1 by everything, or just turned everything negative, or flipped the sign, you'll get -x squared minus 2x minus 1. All right, hopefully you followed me on this one. All right, that concludes section 7. We're going to continue to talk about transformations in section 8, but we're going to be looking at how it affects the independent variable. So I'll see you there.